This is the worked solution for AQA GCSE P3 June 2014 question 8. The first part of this question is about hydraulic systems. We should underline any key information that is given to us in the diagram because we may need to use this later. Hydraulic systems are used to transmit a force, in the next part of the question, it wants us to calculate the force the liquid applies using the pressure on the platform. So the question gives us pressure, it wants us to calculate force, and we need to look at the formula sheet to find an equation that links those two. And the equation that we're going to use is pressure is equal to the force applied divided by the area it is applied across. The value for area was given to us in the last part of the question, and we're given pressure. So writing these numbers in, 8.75 times 10 to the 4 is equal to force divided by the area, which from the last part of the question was 1.76 times 10 to the minus 2 meters squared. So to rearrange this, we need to multiply 8.75 times 10 to the 4 by 1.76 times 10 to the minus 2. That gives us 1,540 newtons. There are several correct answers to part C. It tells us in the question that extracting plant oil requires less energy than extracting oil from underground wells. If it requires less energy, then it requires less electricity, and an environmental advantage of using less electricity is less CO2 will be released. Other possible answers include the fact that plant oil is renewable, and using plant oil will conserve limited supplies of crude oil or underground oil, or extend the lifetime of that underground oil. The final part of the question is about the force that results from when an electromagnetic field caused by a current interacts with a permanent magnetic field around a permanent bar magnet. To gain all the marks available for this question, we have to explain every bit of our understanding of how electromagnetic force comes about. So we need to state that the current flowing in the coil creates a magnetic field. This magnetic field interacts with the permanent magnetic field from the bar magnet. This causes either an attraction or repulsion. So this produces a force and the cone moves. In the diagram it tells us that it's an alternating current, which means it changes direction. So when the direction of the current changes, the direction of the force also changes. This makes the speaker move in and out.